All right, where do I start? Well, I guess I should start with two words. Thank you. Thank you all. All of you who commented, all of you who participated in the last version or the last episode of this video, thank you from the bottom of my heart. So here's where we are. I posted in the comments section of the last video, and this is part 2, by the way. If you want to see what I'm talking about, go back and see part 1 first if you haven't already. But one thing that was happening was, first of all, you see these two multiplex chips, and their whole point in life is to bring in these resistors here, and which of course this is how you calibrate the thing, and to bring in these current sources, and this is for the inductance test portion of the LC-102. And these multiplex or MUX chips, as I'll call them, are driven by IC12, which is this 74 C374. And this is just a flip-flop. What is it? Octal flip-flop chip. Now, one thing I noticed was this chip would get warm. And when this chip got warm, that's when, if you recall, these power supply, linear regulator chips would start to get warm. And I saw a correlation there. So as you notice, I pulled that chip, and I have a socket in there right now, but I pulled the chip. In addition, while I was in there, I removed all of the transistors and just the capacitors, and I recapped it. Got rid of the electrolytics. Some of you suggested that you had seen a lot of problems with the electrolytics on these, so I just replaced them. I had them in stock. They were cheap. It was easy to do while I had the board out, so I did it. I removed those LEDs on there. I also took this PROM and I made a couple of new ones. So I have a new version 15, which is the one that's in here, and I basically copied this chip onto here. And then I also made a version 17 that I was able to download from a website online. And if you notice, the ones that I have here, they're MC 27C256s. I don't know if you could see that. And this is also a 27C256. However, there's a big difference. These ones are PROMs, programmable read-only memories. But if you peel back the sticker on this one, and I'll zoom you in, you can see that this one actually has a window in it. And it is an EPROM, or an erasable programmable read-only memory. That means that you can put this in a ultraviolet light oven, I call it. I have one here somewhere. And you can erase the chip and reprogram it. These ones are one and done. Once you flash them or burn them, they're permanent. You can't erase them, you can't change them. But that's okay. Other than that, they're the same. I'm going to leave this one in for right now. When we last looked at this, the big problem was all of the signals on this microprocessor chip just looked wrong. And I suggested that maybe we either have a bad ROM or a bad microprocessor, and that it was very rare that I had ever seen these go bad, in my experience with this type of equipment. Or not this particular test equipment, but the equipment that I work on in my day job. And I said more likely, if it is one of the two, it would be the PROM, because these just don't fail that often. Now, a couple of you took note when I showed the waveforms on here that there was some significant offset on some of these, indicating that something was shorted. And it's kind of strange, because just as I was finding that these were getting warm, one of you made a comment online to say, hey, if there are any multiplex chips or anything on there, check them and make sure, or any shift register chips or anything like that, check them and make sure one of them isn't shorting. And I just took, this one was getting warm. The rest of them were not. I also noticed that these two were getting a little bit warm. but they weren't getting hot. This one was, so I pulled it. In addition, when I looked at this circuit, which is these 4051s, which is these two right here, this is not drawn correctly. I believe this was supposed to be a voltage follower circuit, and if it is, if you notice, this is just would be a dead short. This, why have this chip here if you were going to have just a wire going across it like that? So what I really think this was this is not supposed to go to ground. This is supposed to connect to this pin 3, and this is this pin 3, or something like that. But this is definitely drawn totally incorrectly. And if you measure it, in fact, pin 6, which is the output of IC26, does go to pin 3 of IC17, and pin 2 goes to pin 3 of IC16. So that part is correct, but we don't have a short between these two. And so, long story short, this is incorrect. That being said, I don't think that's the problem. I think the problem is back here, because even though this was all acting strange, and believe it or not, on this pin 3 here, I was seeing 18 volts, which there is no 18 volt supply. There's a plus 12 and a minus 5. So I guess the differential between that would be 17 volts. You know, if they're a little bit high, I could see 18 there, but really weird. But the one common thread to all of this comes back to that IC12. And that's why I pulled it. So I desoldered it. It took some time. I plugged the board back in and I recapped it, and that's where we are right now. So what I'm going to do is I'm going to get the oscilloscope back out, and I'm just going to try to measure those points again to see if anything changed. So here we go. I have it turned on. Let me plug it in. Let's turn this on and see what happens. Wait a minute. Ha! It booted. Okay. It's working. It's actually working. Wow. We have a bad chip. So this is a 74C374, and I'm going to have to see if I have some of these. Now here's the thing. I used to have gigantic plastic tubs full of all the 40 series and 74 and 74LS and 74HC series chips. I mean, even the strange ones that you didn't use very much, I had, because they were just everywhere in the X-ray industry. Old X-ray machines were just loaded with this type of logic. So we used to carry huge quantities of these at work, and most of them unfortunately are gone now, but I do have a stash of some of these. Let me see if I have one. All right, so here is what I have left of my 74 HC series and its 74C series. Let's see. 74HC373. Is that what I needed? 74HC374. Crap. And, well, actually this is a 74C, not an HC. And yes, there is a difference. Some of them are high current, some of them are low power Schottky. Depends on that letter in the middle. So no, I do not have one, and we're going to have to order some. Unless I can dig through some of my other things at my warehouse, at work. If I can't find one, I think we're just going to have to wait until I can get some in. But hey, good news. It's working. It's booted up. Alright, it is a couple days later, and I was able to get my hands on some 74 what is it, 74C, what is it? Yeah, 74C 374s, I think they are, if I'm not mistaken. And I got it plugged in, and you remember it booted up, and of course it didn't work because we were missing one of the chips. But let's try it out now with this chip in here and see what it does. And there it is, it boots up. I don't know if you could see the display on it or not. There we go. So let me move the camera down. So that means that that chip was the problem. Now I think what I'm going to do right now is, before I do a whole lot, I'm going to just kind of wait and make sure nothing goes flaky, and make sure that there wasn't something else that was loading that chip down, although I don't think so. I think that chip was bad. Just kind of touching things. I mean, nothing is getting even remotely warm now. I mean, by now, several of the components, especially the voltage regulators, would be getting warm already. And they're ice cold. They're not, I mean, not even warming up at all. So I think maybe that was all that was wrong. The capacitors on the power supply, or on the leakage supply board, and this one chip. So far, that's all we've replaced. Now I've also, if you can see there, I installed one of the PROMs that I burned on my PROM burner using the firmware that I downloaded, or copied I should say, off of my old PROM. And well, it booted, so we must have a good PROM too now. Alright, now let's go up and see if we can look at the scope at some of the test points now once again. Alright, looking at my reflection in here. Hi everybody. Let's go back to looking at the schematic. Let's go back on the microprocessor, the ADC39AP microprocessor. Let's once again look at our clock, which I think is right here, is it? Yeah, there's our little clock pulses. Okay, and again, I have the voltage scale off a little bit, but that's okay. Let's see here. Let's go to 2.5 volts per division. All right. And I can expand the time base, but I can see it's okay. Yeah. And of course, we're getting all kinds of aliasing. This scope, I have to change the settings on it. I'm just too lazy to do it, but everything is there right now. All right, so let's see if we can look at the ALE. Hopefully I'm on the right pin here. Yep. And let me get set my trigger. Wait a second. And why is it rolling around on us? Okay. Let me set my scope here. Give me a second. Okay, I was on the wrong time base. We were getting that weirdness again. Okay, you have to make sure you're on the right time base when you do this. So you have a wee little bit of ringing up here, but boy, much better than it was. Let's look at some of the data bus lines. So there's one. Okay, and let me see if I can change my trigger. Okay, this is a data line right here. This is what data should look like. You know, I can open it up a little bit and it'll start jumping around because we're really not locking onto it. And I can check all of them. And it doesn't have that funky offset on it anymore. So I think it's working now. I think it's working as it should. So let's see if we can get it to zero the probes. Okay. put this in here. And the first thing we're going to do is we will do the, let's see, we'll do the open probes first. I don't know if you can see what it's doing, but I just have a dash right here. Hard for me to see the reflection in the screen of the camera. And it doesn't seem to be zeroing, but we'll let it go for a minute or two because it should give an error if it can't zero. So we'll wait. I'll come back here in a second. Okay, I don't believe this is working, so I took the probes back out. What's supposed to happen is when you open the leads and you hit lead 0 open, it should say open here, I believe, and then after a second or two it'll clear, and then you short the leads, hit this button down, and it should say short, and then it should clear, and then it's ready to go, and then we should be able to hit the value and it'll measure the cap. None of that is happening right now. So what I want to do right now is see if all of our data buses are still working. I have a feeling we're either going to have bad transistor somewhere or a MOSFET, or we may have some bad chips over here too. I don't see all of the display working properly either, so it's possible we still may have some bad components in here. So I'm going to have to do a little more digging. Okay, I think we still have a problem related to some of these things, and that is, I don't know if I said this earlier in the video, but this is improperly drawn. We know that. It is not correct. But if I look at pin 7, it very clearly says that there's a plus and minus 5 volts on this op amp. And when I measure it there, it is not 5 volts. And looking at the scope, I'm on 5 volts per division. And if I go on pin 7 of that little chip, if I can do this on the camera here, I don't know if you can see it. Yeah, there's 18 volts there. Look at that. And it's a solid 18 volts DC, and if I go down and look, the same thing with the meter. Here's the meter. I have, with the camera in my way, 18.48 volts. That's way excess what should be on that chip. So first of all, that chip might be damaged. Second of all, why am I getting 18 volts on my 5 volt line? So let's go back. Hopefully I won't damage any chips while I'm waiting to look at this. But let's find some other places where 5 volts is present. And I mean, according to this, if you look, there's just one place where the 5 volts comes in, and it's on that P6 pin 2. And if I go to P6, which is back here, what is this right here, pin 2. You see, I think this is pin 2. Wait a minute. Yeah, pin 2. 1, 2. That's negative 5 volts. Hold on, am I looking at it wrong? I'm looking at it wrong. Never mind. Idiot. Pin, it's actually P. It's so hard for me to see around this camera. P6, pin 3. Let me go over one more. And you can see it's very clearly 4.96 volts. It's 5 volts there, but it is 18 volts here. So what WTF? What's going on here? There has to be another source for 5 volts on this board, and I'm just not seeing it. So I will need to study this a little more and find out just what's going on. Okay, here is IC33, which is also a TL081. It is right here, and very clearly the same way it's marked. Pin 7 is plus 5 volts, pin 4 is minus 5 volts, and if I go on pin 7, let me see if I can touch it, 4.95 volts. And of course pin 4, minus 4.91. So, why in the heck am I, and how am I getting 18 volts on this chip up here? So I have a feeling we have a bad chip here, and that would make sense. These are all tied together. I'm probably just going to shotgun these and replace these components because all of them have been damaged, and this is just the one that was on the data bus showing it rearing its ugly head. But I have a feeling we've had a catastrophic failure and we have multiple bad chips on this board. Okay, we are making progress. Again, the only reason I could see that, well, first of all, this is drawn incorrectly. Obviously, you're not going to put a dead short across here unless you're going to try to make this into a voltage follower, in which case this would have to be down here. So this is not drawn properly, and I really didn't take the time to trace the traces out to see how it should be, but neither here nor there. You should never have on pin 7 of a TL081, you should never have 18 volts. That exceeds really the normal operating range of this chip. So I'm replacing this, and of course these are what's responsible for selecting all these different current sources and voltage sources and so forth. So I am not going to take any chances while I have the board apart. I don't want to take this thing apart and put it together 100 times and wear out connectors and wires and things like that. Nor do I want to spend, every time you do that, you run the risk of moving some of these pots, which is going to throw things out of calibration if they aren't already. So I'm going to replace all the components I think are related to this problem, even though I don't think all of those components are bad. The owner of this that sent it to me said that it failed while he was using it, and he was in the process of batch testing capacitors. And I think what may have happened is one of these relays here somewhere may have not properly switched in or out, or perhaps the capacitors were not being properly discharged. This is a discharge resistor here. This is what the purpose of these resistors are, is to discharge the capacitors when they're done being tested. And there may be something that got into here and damaged one component, which then put undesirable voltages on other components and caused a couple of them to fail. And I think the person who was servicing this, who was originally began repairing it, was starting to go through, and he found the power supply issues, and that's why that one regulator was replaced, and a few then this transistor here and a couple things, and he hadn't had the opportunity to go through the rest of this. So I'm kind of starting to figure out the history and what's going on here. But that being said, I am putting these up on sockets, and I'm going through any chip that I think might possibly have a problem or have a future problem. While I have it apart, I'm going to replace it. Okay, the unit is all back together. The leads are connected. And again, I don't know if these leads are good. This is all really critical with this thing. It is really finicky about test leads and all kinds of things, but let's see if it still boots up. That's a good sign, so it comes on. All right, let's see if it'll pass the open test now. Because you remember, it would just lock up. Okay, that did it. Now with the short test, I think it was the shorts one that locked up. So let me short out the probe. Okay. I just clipped them onto a lead together, and okay, I think that dash is supposed to go across there, but if you notice, it cleared that time. Alright, now this is probably not going to work. This thing's probably grossly out of calibration, and these machines, if not calibrated, will not work. So I'm going to go in here, and I should be able to just push, let's see, aluminum electrolytics, and I should be able to just hit capacitor value, and it should read something. Error 7. Okay, error 7 is out of range, and that means that it's out of the measurement range of the equipment. Of course, this is only a 100 microfarad capacitor. So either we have something wrong with the leads here, or we have something wrong still maybe with a calibration or something. But from what I can see here, this thing's working. You know what I should have done before I even did this? I kind of got all excited. Let's see if our 18 volts is gone. Because if you remember, the whole reason we started all this is because we had problems over in here, and this is incorrectly drawn, and this 5 volts had 18 volts on it, and all the rest of them had 5 volts like they were supposed to. So let's measure. I would definitely say we've made some progress here. Okay, so 1, 2, 3, 4, 5, 6, 7 is right here. And I'll be daggone, it's still 18 volts. It's 18.4, it's actually too high. So there is an 18 volt supply on the chart on the leakage supply board. And if we look at it, it's coming out right here on P4 pin 7. And it's this LM317. So maybe not only is the wiring drawing incorrect on here, but also this may be genuinely connected to the 18 volts. So let's turn this off. Let's disconnect the power. Let's go into ohms, and let's just go from pin 7. Let's see, where does it come in on? The 18 volts is coming in on pin, there it is right there, P6 pin 4, right? So I'm going to go to P6 pin 4 to this P7 here, and I should see, if I'm right, that's weird. So 1, 2, 3, 4. And let's see if I can get on it. Sure enough, dead short. You see that? So it is connected to the 18 volts. Of course, I should have checked that before. However, so this most likely was not the problem, but one of these definitely was a problem because we weren't able to do anything before, and now we're just getting an error 7, which leads me to believe this thing's working now. And I think our next step is to just try to go through the calibration procedure as indicated. Now, we could have a bad set of test leads, because these I really didn't check to see if they're the correct ones or if they are even good. And I did not check well, I did check the relays. This relay is perfect, it's cleaned. This one, I have a spare one of these actually, but I think it's good. I don't see anything wrong with it. They both read good. These have been all replaced with brand new ones. So we're really down to calibration. And that's what we're going to do on the next episode of this, or next part. We'll come back and we'll go through the calibration. Now, I'm not going to have all of the components to do the full calibration. especially some of the inductors. I don't know if I have them, especially when they want ones that are like 0.1% accuracy. I might have some that are less than that kind of tolerance, but of course that's going to greatly affect the accuracy of the meter. But we will at least have enough components to go through this and kind of rough it all in and see if it works. And then if everything's working good, I may then go ahead and order the dozen or so individual high precision components, because they want the resistors to all be 0.1%, which those are, you know, instead of a 10-cent resistor, it could be a $2 resistor to do that. So we could end up, you know, putting $25 or $30 into parts to do that. But let's make sure that we can roughly calibrate it first with close to the right components and see if it works, and then we'll go from there. But that's for the next part. So hope you're enjoying this. This is my last test equipment video I'm going to do for a little while, because we're going to go back and do some other fun stuff. Maybe some I have a couple other pieces of audio gear that I really want to get on the bench, and I'm kind of excited to work on. So until next time, I wish you all peace, joy, happiness, and good health in your lives. And I hope to see you again real soon. And one last thing, we also may need to take a look at these two diodes here, these pico amp diodes. These are part of this current source in here. So these, I've read a few things online that they go bad. So I have those actually from, I think there was some other, I can't remember what it was from, but I think I have some of these. So if I need them, we got them. Anyway, that's it. Take care. Bye-bye.